We are continuing with number systems. We'll first look at representation of rational numbers on a number line. Then we'll see comparison of rational numbers. And then finally, we'll see how we can insert rational numbers between any two given rational numbers. See how we place rational numbers on a number line. So previously we have already seen how we place integers on a number line. Now let us extend this knowledge to rational numbers. So we already know that on a number line we have 0 and all numbers to the right of 0 are positive and all numbers to the left of 0 are negative. Now say if I want to represent the number 3, say I have 1, 2, 3. So this is where 3 will be represented on the number line. Similarly, -3 will be placed here. So now say if I want to represent a rational number such as 5 by 4. Now first, what is 5 by 4? 5 by 4 is nothing but 1.25. So 5 by 4 will lie somewhere between 1 and 2 on the number line, but on the right side. So we just need to represent it somewhere here. This is 5 by 4. Similarly, minus, say we have minus 5 by 4. Where will minus 5 by 4 be on this number line? So it will be equidistant from 0. So it will have maintain the same distance that 5 by 4 is located from 0, but on the opposite side, that is towards the left of the number line. So this is where minus 5 by 4 will be. So this is how we represent numbers, rational numbers on a number line. Now let us understand how we can compare rational numbers. So this builds upon what we have already known about comparing integers, fractions and decimals. So there are a few key rules that you need to follow when you're comparing rational numbers. Firstly, a positive number is always greater than a negative number. Say for example 2 by 5 is greater than say -3 by 5. Secondly, 0 is less than any positive rational number, but it is greater than any negative rational number. So for example, if say we have -4 upon 7, we know that this is lesser than 0, which is in turn lesser than say 4 by 7. Thirdly, whenever we are comparing say two positive rational numbers, let us see an example. Say we have 7 by 12 and 9 by 16. So to compare these two, we first find the LCM of 12 and 16, which is 48. And now we rewrite these fractions so that the denominator is 48. So 7 by 12 can be written as 28 by 48 and 9 by 16 can be written as 27 by 48. Now clearly I know that 28 by 48 is greater than 27 by 48. So 7 by 12 will be greater than 9 by 16. Okay, now fourth thing is how we compare two negative rational numbers. So let us understand by example. Say we have to compare -5 upon 8 and -7 by 12. In this case also the steps are the same. So we just find the LCM of 8 and 12, which is 24. So I simply rewrite this both of these rational numbers so that the denominator is 24. So -5 by 8 is -15 by 24 and -7 by 12 will be -14 by 24. So now I know that -15 is lesser than -14. So -15 by 24 would be lesser than -14 by 24. So in turn, minus 5 by 8 will be lesser than minus 7 by 12. So this is how we compare two negative rational numbers. Now let us see how we can insert rational numbers between any two given rational numbers. So first of all, between any two rational numbers, there are infinite rational numbers which can be inserted. Let's take an example. Say we have 3 upon 7 and 5 upon 7. So you may feel that there is only one rational number in between, which is 4 upon 7. But this is not the case. So to understand that, let us just rewrite these given numbers with larger denominators so that we have more room. Okay, so I can write 3 by 7 as 30 upon 70, because we have seen earlier, these are equivalent rational numbers. Similarly, 5 upon 7 can be rewritten as 50 upon 70. Now as you can see, there are a lot of rational numbers between 30 upon 70 and 50 upon 70. Say 31 upon 70, 35 upon 70, 40 upon 70, 45 upon 70. Now as you can see, all these rational numbers, they lie between 30 upon 70 and 50 upon 70. So you can simplify these fractions further if required, but I would like you to understand that between any two rational numbers, there are infinite possibilities. There are infinite rational numbers between any two given rational numbers. Okay, so from this video, I want you to have three takeaways. Firstly, that the number line is divided at 0 with positives on the right and negatives on the left. Secondly, whenever we are comparing rational numbers, we compare them systematically. We use common denominators to compare rational numbers. Thirdly, it is about the infinite possibilities. Between any two rational numbers, there are infinite other rational numbers.